My advice be pick points along the blue line. Figure out what they're telling you, those points, and then tell a story. Yeah, I did. Thanks. Okay. Thumbs up when you have a guess. Tell your neighbor what you think.
I avoided them as much as remember like positive. Yeah, I remember Oh yeah.
That was a hike. You're not the only one. Okay. Correct answer is E. Everybody good with E? Okay. How are you moving here? That point. Fast or slow? Fast. Positive or negative? Negative. Fast or slow? Slow. Positive or negative? Stop. Slow, positive. So what happened from here to here? Turned around. That makes sense? You crossed from negative land to positive land. Okay? Fast or slow? Positive or negative? Good with that? So put it all together. Started fast, slow down, stop, turn around, sped back up in the positive direction. Okay? Thumbs up when you have a guess. Have a conversation. Tell them why.
yesterday.
Tell your neighbor what happens here. Okay. What do you say? Correct answer is B. What happens at this point right here? You turn around? Sure looks like a turnaround to me. In order to turn around, what would you have to do? Go from positive land to negative land. This is a turnaround. This is just a slow down and then speed back up, still going in the positive direction. Good with that? Popular wrong answers say you turn it around. It kind of looks like it, but you never switched. Okay? Here's the next level of difficulty. I give you a position versus time graph, and you tell me what the velocity versus time graph looks like. Thumbs up when you have a guess. Have a conversation. Tell them why.
I'm like trying to look for the zero. I'm like, I don't see it. And I'm like, oh wait, there's nothing. What do you think? Considering my Spanish.
Correct answer is? Nice. What on a position versus time graph tells you velocity? The slope. What is the slope of this line? 0. The slope of this tells you the value, the number of that. Next question. Thumbs up when you have a guess. Talk to your neighbor. On position versus time or velocity? Position versus time means you're going on the y-axis, you're going towards 0. So like you're going down. Yeah.
So it'd be like under
What that one is. So it's not speeding up or slowing down.
Welcome. So like in math class, that you'd say that's a negative slope. This would be a positive slope.
Speeding up or
so
slowing
would you
down
like
for the position.
Well, I'll let you guys discuss that. But
For the position. Like if that has words to it, basically saying, oh, it's slow, then it's fast.
What do you say? A? A. Okay. Tell me, is this a positive or negative slope? Negative. So we're where on velocity? Below the x-axis. Does that make sense? Somewhere in negative land. Is that slope constant or is it changing? Constant. So the value of velocity is going to be constant as well. Gives you a constant negative velocity. Your cruise control is locked, is set, and you're going in the negative direction. All right with that? My suggestion would be to take it in chunks. So in your brain, without involving your mouth or hand signals, without influencing or being influenced. Thumbs up when you have a guess. Have a conversation. Tell them why.
Oh wait, I have a question. Like I noticed, but like, because I guess it's fast in the direction. I don't know. So I don't know how to.
Correct answer is C. C, C, C. This chunk right here, is it going fast or slow? Fast. In the positive or negative direction? Negative. Where on a velocity versus time graph would you find the point fast negative? Below the x-axis, far away from zero. Fast or slow? Slow. Positive or negative? Negative. Where on a velocity versus time graph are you going to get moving slow in the negative direction? Still in negative land, close to zero. Connect the dots. That makes sense how I took that apart? Okay, last shot. Thumbs up when you have an answer. Tell your neighbor. Tell them why you came to that conclusion.
C and D, and then you would have after C and then it starts fast. So it's E, get closer to C.
Okay. What do we say? B. Fast or slow? Positive or negative? Where do we find fast, positive on velocity versus time graph? Above, far away from zero. Fast, slow? Positive, negative? Where do we find slow, positive on velocity? Connect the dots. Good? Okay. We are going to do a lab today. That incorporates these motion graphs. So over here, so you're going to need a Chromebook per group, but I would suggest everybody downloading the app. It's Veneer Graphical Analysis. The icon's right there. Go to the App Store, the Chrome App Store, and download that. Inevitably, you're going to need that at some point this year. Okay. So you're going to be plugging one of your computers up to this. It's the computer interface. Sometimes I call this the brain. And then the device that we're going to be using is a motion detector. Okay. This motion detector works kind of like echolocation or sonar, like a bat locates a bug. It sends out a sound, and that sound wave goes and hits the nearest thing and bounces back. This knows the speed of sound and can calculate how fast, how long it takes to go there and back, and using that can calculate how far away that nearest object is. And it does that rapidly, repeatedly. Okay, and so from that, it can create a position versus time graph and a velocity versus time graph in real time. It's pretty cool. Okay, so make sure you have a clear runway. Like you're going to be going back and forth with that. It's about, like, give it about a foot or so. It gets all wonky when you get really close to it, but like give it a foot. You have about this much space of a range, about that far ish. Okay. Recommendations would be to make your fast fast and your slow slow. Like the bigger the contrast, the more apparent it's going to be on the graphs. To make it easier for you, your position versus time graphs are going to either be straight lines or curved lines or curves. Your velocity versus time graphs are either going to be horizontal lines or straight lines. Okay. Here is an example of what your computer might give you. Set, go. Okay. Here's what you're going to draw on your lab. Okay. I don't care about values. You just give me the trend line. Okay. When it says overlap previous trials, there's a button right here. For one of the graphs will be position. Click on that and it'll list all the different trials that you did. And then click on which one you used from the previous one to like put both graphs on so you can compare and contrast. Now, killer with this program is it has a tendency to zoom out really far. And so you get lines, especially on velocity, it looks like it's just zero the whole time. It's not zero. If you look at the scale, it's probably like 100 meters a second is the highest point. There's no way in the world you're going to be moving 100 meters a second. Okay, that's just, it's capturing this crazy noise. So it's kind of like on Google Earth when you're trying to find your house and you see the picture of the United States, you see a blue dot in northern Indiana. Like, hey, I live in northern Indiana. You have to zoom in to actually see what's going on where you live. Does that make sense? So you can zoom in. There's a magnifying glass on that. You can select the part that you want, but no, it's going to get messy. It'll zoom really far in. So just kind of go with it. Do your best on that one. So I'm a big fan of mixing things up. So I'm going to assign you your groups. Remember your number. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Here is where you're going to go. Group 1, here's your runway. Group 2, Group 3, Group 4, Group 5, Group 6. Go.